Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn how to graph inequalities that in two variables that are not linear. In this first example, we'll be working with a parabola, and in the second example, an absolute value function. So for this first example, this is a parabola. I know that I'm going to graph this with a dashed curve because there's no equal sign, so the graph itself is not a solution. No point on the graph is a solution. I know the vertex, this is an HK form. The vertex is 3, -4, and it opens up from there. So 3, -4, I've got a point there. I can try to find the x-intercepts, and you can do that on your own here. Pause the video if you want to practice this, but we set the expression on the right equal to 0, square root both sides, etc., etc. We find that the x-intercepts are at x equals 5 and x equals 1. If I wanted more points on here, I could find the y-intercept by substituting 0 for x. When we plug in 0 for x, we end up with 3 squared, or 9 minus 4, which is 5. And I know the axis of symmetry is here. That's 3 to the left, so I could put another point that's 3 to the right. I also know from the vertex, I can get another set of points by moving up 1 and out 1. And again, the more points I have on here, the easier it's going to be to draw a precise graph. All right, so there is the parabola, dashed or dotted to indicate that those points are not part of the solution. And either I'm going to graph above the parabola, which you may think of as inside, or I'm going to graph below the parabola, which you may think of as outside, and use the same approach as we did in the last video with linear. We're going to pick a point that's not on the curve. And 0, 0 is not on the curve. That's actually below the function. So when I put in 0, 0 to this inequality, y is greater than x minus 3 squared minus 4, is 0 greater than 0 minus 3 squared minus 4, which is negative 3 squared minus 4, or positive 9 minus 4, or 5. And 0 is not greater than 5. Now, I know in all the examples I've done so far, they've been false. It's not always going to be false. It works out to be about 50-50. But that tells me that this is not a solution, and so the solutions must be on the other side of the curve, which here would be above the parabola, or you can think of it, right? It looks like it's inside, but it's really above. Now, in this example, whenever we are graphing a function of x where y is isolated on the left-hand side, then this sign really does tell us how to graph it. It's just that when y is not isolated that we cannot tell for sure from the sign which way to shade. But anyway, in this case, we shaded above the curve. And again, that means that any point that's in here, so if I pick this point, which is 2, 6, I know that that's a solution because that's in the shaded area. All of the solutions are in that shaded region. One more. Y is less than the absolute value of x plus 4, all minus 5. Now, y is isolated here, and because it says y is less than, I know that I'm going to be shading below. It's probably not a bad idea to continue to use the test point, though, so that when you run into the case where that's not the way to do it, the test point will tell you which side to shade. Absolute value, it's V-shaped. The turning point, HK, is -4 for h, -5 for k. This one does open upward, so -4, -5 would be here. And from that point, it goes up 1 and out 1. So I'm going to go up 1 and 1 to the right. It's kind of like having a line whose slope is +1. And then to the left, it goes up 1 and 1 to the left. On this side, it's like having a line whose slope is -1. Now, this one is going to be dashed because the inequality sign does not contain an equal sign underneath it. So something like that. Again, I know that since y is isolated, I'm going to be shading below, but we should get the test point. A good choice for the test point is the origin. If you can tell that it's not on the graph, and here it's slightly above and to the left of the graph. So my test is going to be 0, 0. I'm working with y is less than x plus 4 minus 5. 0 is less than x, 0 plus 4 absolute value minus 5, which is 4 minus 5 or -1. This is false. That is not a solution. And all the solutions are going to be on the other side of the graph. So that graph is like a dividing, it's not really a line, but a dividing wall. Either the solutions are on one side of the wall or the other. When the point you pick doesn't work, jump to the other side of the wall. So here, that's where we find the solutions. All right, that's it for this video. In the next video, we'll take a look at what happens when we have 2 or more inequalities to work with at the same time.